All right, we have a chemical reaction here that's first order. And it's important to realize that we start out with 100% of A. And after 1 hour, it says right here, 1 hour, 75% of this substance reacts. So it means 25% remains. So it goes from 100 to 25 over 1 hour. And then we have a second, the question in this word problem. So the first step here is to realize that we have a first order reaction. And we need to use the integrated rate law for the first order reaction, which is this formula here. Okay, now to find K, we want to divide both sides of this equation by time. And plug in the values that we were just discussing. So initially it starts out at 100, and it ends up to be 25. And that occurred in 1 hour. So let's punch this all into our calculator and see what we get. I get 1.386 reciprocal hours. All right, that's the rate constant for this chemical reaction. Now we want to deal with our question here. How much of A will react? Will be left unreacted at the end of 2 hours if the reaction is, first order. Okay. So what we want to once again do is find the amount. So we're starting with 100%. Okay. And this time we're going 2 hours. Okay. And we want to know how much of A do we have at that time t. So let's go ahead and use once again the integrated rate law, integrated rate equation for the first order reaction. And here we want to solve for that variable. So we want to move things around. Let's go ahead and subtract. Whoops. Natural log of A 0. And let's multiply both sides by -1. Get rid of that negative there. All right, and on the right-hand side here, let's just evaluate what we have. K is 1.386 reciprocal hours. Time is 2 hours. Okay, and then we want to add the natural log of A naught, which is 100. Okay. And let's see what we get. Punch this into your calculator. Okay, and I get ln AT equals 1.833, something like that. Okay, hit the Shift LN button or E to the X button. And what I get here is that A at time t is equal to 6.25%. That's the amount that's left unreacted.